All right, and what we're going to do today, there's a document that I want to guide you all through on how to find it because we're going to use it as we go through some of the things we're going to talk about today. In the lecture notes section, close some windows down. In the lecture notes section in chapter 9, in this 9.4 document, there is this um, PowerPoint called inverse functions, and I'm going to bring this up. Okay, and we're going to use this a little bit later in the course, but I wanted you to know where this document is located. So once again, that's on the formula, in the lecture notes section. Okay, it's under chapter 9. Okay, and it has its own little PowerPoint, and it's this inverse function worksheet. Okay, we'll need this inverse function worksheet, and we're also going to use the unit circle, I believe. All right, so I'm just going to go back to the main page, and on the formula sheets, I'm going to bring up the unit circle. Now, I actually want to begin class today by you solving a problem. And this is in a section 2.3, the last section or the last module of the homework. And at this time, I would like for you to find the angle theta. Okay, so I'll give you about 5 minutes or so to find the angle theta, and then we'll kind of return with the solution. All right, so we're going to return with the solution. When we're asked to solve an angle or find any missing dimension in a right triangle, there's always a couple of things you want to look at first. Okay, since we're asked to find a given angle, right? So when solving any right triangle, if you're given two sides, you can find the third side using the Pythagorean theorem, right? Which won't actually help in this problem because we're not actually finding a side length, we're finding a missing angle measure. Conversely, if you're given two angle measures, right, we can use something called the sum formula, and the sum formula just states that there are a total of 180 degrees within any triangle. So we can use the sum formula and we can add the two given angles together. We can subtract from 180 and that will give us our missing angle measure. Okay. But for this particular problem, I can't do either one of those things because I don't know two angle measures. I'm only given one angle measure, which is the 90 degree. All right, so in this instance, we're going to have to set up a trig function. You want to remember that when you set up any trig function, first we must have a reference angle, right? So remember the definition of a reference angle is just any acute angle. So we're going to use the angle that we're trying to find as the reference angle. And then we want to use something called chief SOHCAHTOA. So I think I may have alluded to this earlier. Chief SOHCAHTOA, right? It is a mnemonic device, and it's really just a saying that helps us to remember, in this case, the 6 trig functions, or at least the 3 main trig functions. And from the 3 main trig functions, we can find the reciprocal functions. Okay. So I'm going to utilize chief SOHCAHTOA. So first we have our reference angle, right, which is the angle we're trying to find. After we establish a reference angle, the next thing we need to do is label all of our sides according to the reference angle. So I always like to start with the hypotenuse, and keep in mind that the hypotenuse is always opposite the right angle. Next, I'm going to write out the side that's opposite. So notice here we have our given angle that we're trying to find, and we have opposite. Okay, the side opposite to that angle is the side that's opposite. So we have the opposite to our theta. And then lastly, I'm going to set up the adjacent, or label the adjacent. So we have adjacent to our unknown angle theta. All right, so which trig function can we utilize to find a given angle measure? Well, notice that when I set up my trig function, okay, I must know at least 2 of the 3 unknown, well, 2 of the 3 items. So here I don't actually know my angle measure, but I know the opposite and I know the hypotenuse. So looking at the chief SOHCAHTOA, we can actually set up a sine function. I can write this out as the sine of theta. That's going to equal to the opposite, which is 8, divided by the hypotenuse, which is 13. And now I must find the given angle theta. So what I'm going to do here is I'm going to take the arc sine of both sides, right, of this equation, right? From algebra, whatever we do to one side, we have to do the exact same thing to the other side. So I'm going to take the arc sine for both sides. So what happens on the left-hand side, the arc sine of the sine of theta is theta. And we're going to talk about this left-hand side. Okay, but in general terms, as far as solving these trig equations, this is basically what's happening in the background, right? So it pops out theta and identity on the left-hand side. On the right-hand side, I'm just going to bring down the arc sine of 8 over 13. To evaluate the arc sine of 8 over 13, I'm going to use a calculator. Right. So first off, I'm just going to make sure that I'm in radian mode. I'm going to put in the arc sine, which is second in sine. I'm going to put in 8 divided by 13. Right. And we have 0.66. All right, so our given angle measure is 0.66 radians. Okay. All right, I just wanted to go through that. I believe there are a couple of problems in the section 2.3 homework that asks you to find a given angle measure. All right. So once again, you'll label all of your sides according to the reference angle. You use Chief Sokotoa, right? Set up your trig function and evaluate. All right, now I'm going to talk a little bit more about these arc functions or inverse functions. Okay, I'm going to refer back to the document, the inverse function document. Okay, let's see. All right, so there's a couple of things we want to pull out from this particular chart. And what we want to pull out is the first column, right, where we have all of our arc functions. So this very first arc function is read as the arc sine of X. It's also read as the inverse of sine. Okay, so you may hear me say arc sine. I'm used to saying arc sine, arc cosine. But you may see it written out as inverse sine or inverse cosine. All right. Now what we have are the inverse function. For example, this arc sine, and the arc sine is found within the interval from -π/2 to π/2. Okay, now we're not really worried about the domain, right? But what we're most interested in are the intervals in which we can find these arc functions or inverse functions. So let's look at this -π/2 to π/2 as far as the unit circle is concerned. All right, so here I have the unit circle. And notice I have a π/2, but I don't actually have a -π/2. Now, we've talked about negative angles before. All right, and for negative angles, right, so here is, I guess, the unit circle on an X and a Y axis system. -π/2, right, is actually 270 degrees or 3π/2 radians. And then we have +π/2 at the top. So that means that the arc sine is found in this interval from -π/2 to +π/2. All right, you can find all of those things along the right half of the unit circle. All right, now just one thing about the unit circle. Okay, it only lists out positive angle measures. And my lines are disappearing. All right, so what I'm listing out here, if you're asked for an arc sine value, and if that arc sine value is in the fourth quadrant, you must list out the angle as a negative angle, right? So if I kind of align this to the unit circle, okay, hopefully I can stack both of these things. Okay, I want to concentrate on this fourth quadrant. All right, so notice on the unit circle, if we're looking at the fourth quadrant, all of our angles are positive. However, when we list out the arc sine angles, if that angle is in the fourth quadrant, it must be a negative angle. So what I'm sort of alluding to is that 11 pi over 6, right, which is 330 degrees, is actually negative pi over 6. Right. Next, we have 315 degrees, right, which is actually negative 45 degrees. So that's negative pi over 4. And then we have 60 degrees or negative 60 degrees, which is negative pi over 6. Excuse me, that's negative pi over 3. So notice when we're finding these arc sine values that are in the fourth quadrant, we must list them out as negative angles, right? Because the arc sine runs from negative pi over 2 to positive pi over 2, right? So if I were to decimalize these things, negative pi over 2 is, so I'm going to go back to the main screen. Okay, negative pi over 2 is should be negative 1.57, and positive pi over 2 is positive 1.57, right? So the arc sine is in between these values, negative 1.57 and 1.57, right? If you were to evaluate, let's say 3 pi over 2, 3 pi over 2 is not within this range. So if I were to decimalize 3 pi over 2, notice I get something that's outside of the sine, the arc sine function value, right? So you won't use the positive angles, you must use these negative angles. Right? Okay, going back to our function values, the arc cosine, it's found in the interval from 0 to pi. All right, so if we go back to our diagram, here we have 0 and here we have pi. So the arc cosine runs from 0 to pi. So we can find the arc cosine values on the top half of the unit circle. Okay, so hopefully this is going to make sense in just a second. All right, so the arc cosine is found on the top half of the unit circle. We have the arc tangent, and notice that the arc tangent is also found on the right-hand side of the unit circle, and its values are from negative pi over 2 to positive pi over 2. Right, so we can also find the arc tangent. All right, and then we have the reciprocals, the cotangent, the arc secant, and the arc cosecant. All right, but we're going to concentrate on the first 3. All right, so now how are these actually used to answer some problems? All right, so we're going to keep this in mind. So here is the first example. We want to evaluate the arc sine of 1/2. All right. So here we're asked to evaluate the arc sine of 1/2. Okay. So now anytime you're asked to evaluate an arc function, this is how your interpretation should lie. Okay, so we're going to interpret this as what angle, right? Because the answer to an arc function is an angle measure. So what angle in the interval, all right? And if I go back to our sheet, the arc sine is in the interval from negative pi over 2 to pi over 2. Has a sine, and remember that the sine is the y value of 1/2, right? So that's how we're going to interpret this. What angle in the interval from negative pi over 2 to pi over 2, so this is why the intervals are important, has a sine or a y value of 1/2. All right, so now I'm just going to pull up the unit circle. And what did I do with the unit circle? Okay, I must have closed it down. All right, so here is the unit circle once again. All right, so we have interpreted this as what angle in the interval from negative pi over 2 to pi over 2, right? So we're looking on the right-hand side of the unit circle, has a sine or a y value of positive 1/2, right? Well, on the interval from negative pi over 2 to pi over 2, it seems that the angle pi over 6 has a sine or a y value of 1/2. So we can evaluate this as pi over 6. All right, so the arc sine of 1/2 is pi over 6. All right, here is another example. Let's find the arc cosine of negative square root of 3 over 2. All right, so before we pull up the unit circle, let's interpret it. So we're going to interpret this as what angle in the interval from 0 to pi, right? So I'm actually going to pull these intervals from our sheet, right? So cosine, arc cosine, it runs between the interval of 0 and pi. Has a cosine, and remember cosine is an x value of negative square root of 3 over 2. Right? So remember 0 to pi, that's the top half of our unit circle. So I'm looking for an angle in the top half of a unit circle that has a cosine or an x value of negative square root of 3 over 2. right? So it looks like 5 pi over 6, right? It has a cosine or x value for negative square root of 3 over 2. So here we should have 5 pi over 6. All right, now here is an example for you to try. Okay, I would like for you to find the arc tangent for negative square root of 3. All right, so I'll give you 5 minutes or so, and then we're going to return with the solution. All right, so we're going to return with the solution. Okay, so first we're going to just write out the interpretation. So we're going to interpret this as what angle in the interval from negative pi over 2 to pi over 2 has a tangent value, which is y over x, right, of negative square root of 3. All right. All right, so if we look at the unit circle, can remember that our interval for the tangent is negative pi over 2 to pi over 2. This doesn't want to act right. Okay, it does not want to shrink up. Okay, so we're looking for the angle in the interval from negative pi over 2 to pi over 2 that has a tangent value for negative square root of 3, right? So I can look within the fourth quadrant, right? Because all students take courses, the tangent is only negative in the fourth quadrant, right? So I could put the y value, I could divide that by the x value, right, until I get a negative square root of 3. I'm actually going to short the division on that, and I'm going to use, Okay, one of the documents in our course, the unit circle function values chart. So this is basically what I'm going to do. I'm going to look for an angle in the fourth quadrant, right? So keep in mind these angles in the fourth quadrant are 300, 315, and 330. I just want to find out which one of these angles has a tangent value of negative square root of 3. Right? So looking at our sheet, our tangent is in the middle. So it looks like, right, 300 degrees, which is 5 pi over 3, it has a tangent value of negative square root of 3. Right? So I'm gonna keep this in mind, 5 pi over 3. And if I look at my unit circle, right, notice that 5 pi over 3, right, is 300 degrees. But I'm running into a slight problem because for the arc tangent, it must run between negative pi over 2 and positive pi over 2, right? So I can't use the 5 pi over 3. I have to use its negative equivalent, right? So the angle that we're going to use is negative pi over 3, right? So the angle, the arc tangent for negative square root of 3 is negative pi over 3. Okay. Now I actually showed the math on that. So, okay, to actually show that you get negative square root of 3 when you divide y and x. Okay, but what I just showed you was the short. I used the, close that down. I used the function values chart, right, to kind of quickly find which angle has a tangent of negative square root of 3, right? But I didn't use 5 pi over 3 as the answer. I had to use the negative equivalent, right, which is negative pi over 3. All right, but here's the math on that. So the tangent for negative pi over 3, so I will find negative pi over 3, right, which is actually 5 pi over 3. I would take the y coordinate, which is negative square root of 3 over 2, and I would divide that by the x coordinate, which is 1/2. So that's negative square root of 3 over 2 all over 1/2. Right? So there was a formula, I believe I showed earlier. It says that A over B all over C over D. That equals to A times D over B times C. Right? You can multiply the very top and the very bottom, and then you can multiply the bottom of the top. Okay. So you could multiply the very top and the very bottom, and you can multiply the bottom of the top and the top of the bottom. All right. So applying that here, a negative divided by a positive is a negative. I can multiply the very top and the very bottom. So 2 times the square root of 3. And for whatever reason, OneNote keeps crashing. So all right, I can multiply 2 times the square root of 3, so that's 2 square root of 3. I can multiply the bottom of the top and the top of the bottom, so okay, 2 times 1 is 2. OneNote keeps crashing for whatever reason. All right, so I believe you get square root of 3 once. Okay, 2 square root of 3 over 2, that cancels, so you get negative square root of 3. So the tangent of, okay, I got to do something else. The tangent of pi over 3 should be 1/2. All right, so I am going to switch up to the camera. Hopefully this is going to work. All right, so I am now on the camera. All right, so we're going to kind of continue on. And in this instance, we're going to talk more about arc functions. Okay, so we're going to look at, give me 1 second, I had some problems written down. The arc cosine for the cosine of pi over 6. Okay. All right. Now I did mention, I believe in a previous lecture, there is something called identities. Can they look something like this? All right, and when we were solving for angle measures, we take the arc sine or either the arc cosine or the arc tangent, whatever we're dealing with, and it kind of pops out this identity, right? And that's almost this setup, right, where we have the arc cosine for the cosine of pi over 6. This should equal the pi over 6. Okay. Now, in a general sense, this is true, but if your angle is not in the first quadrant, this can break down on you. All right. So from this point forward, right, if you're trying to answer these questions, I wouldn't just assume that the answer is pi over 6, because the angle may or may not be in the right coordinate, and it's always best to work these things out by hand, right? Just solely relying on these identities. These identities are only good for if you're using Chief Sokotoa and if you're, trying to find an angle measure. All right. All right, so here the answer should be pi over 6, but let's go through the process. All right, so just remember from order operations, please excuse my dear Aunt Sally, you want to start with your innermost parentheses, right? So for my innermost parentheses, I have the cosine of pi over 6. So I want to evaluate that. Now there's a couple of ways I can find the cosine of pi over 6. I can find it by using a calculator, right? But most of the times, if you're asked to find an exact answer, the calculator won't help, right? So the calculator is an option. I could use the unit circle, or I can use that unit circle function evaluation chart. All right, so just to show those things, right, we can use the unit circle to find the cosine of pi over 6, right? I can locate pi over 6 radians. The cosine would be the x coordinate, so I would have square root of 3 over 2. I could use the unit circle function of values, right? I could find pi over 6, right? And I could pull out the cosine, square root of 3 over 2. All right. So we're going to evaluate the cosine of pi over 6 as the square root of 3 divided by 2. All right, so now I have the arc cosine for the square root of 3 divided by 2. All right. So now what's our interpretation? So what angle in the interval from 0 to pi has a cosine or x value of square root of 3 over 2? So again, that's what angle in the interval from 0 to pi, so that's the top half of our unit circle, has a cosine or an x value of square root of 3 over 2. Right, so looking at the unit circle, and if we look at the interval from 0 to pi, we want the angle that has an x coordinate of square root of 3 over 2. And it looks like that angle is pi over 6. Right, so the answer to our problem is pi over 6. Okay, so that equals to pi over 6. All right, so kind of worked out in this case because the angle was in the first quadrant. All right, so now at this time, I would like for you to answer this one. What is the arc cosine for the sine of 7 pi over 6? All right, so that's the arc cosine for the sine of 7 pi over 6. Okay, I'll give you a couple minutes to try to work it out for yourself, and then we will return with the solution. All right, so we're going to return with the solution. All right, so here again, we're going to work this from the inside out. And the first thing we're going to do is find the sine of 7 pi over 6. So you should find the sine of 7 pi over 6 as -1/2. All right, so remember that value can be found on the unit circle. It can also be found on the unit circle function evaluation chart. Now we want to find the arc cosine for -1/2. So our interpretation is what angle in the interval from 0 to pi has a cosine which is an x value of -1/2. And if you look in your unit circle, you should see that 2 pi over 3, right? It has a cosine or an x value of -1/2. All right, any questions about these examples? All right, now I just want to guide your attention to, there are some problems that are in the homework. All right, such as like 13 through, I believe, 20. Okay. Now notice this problem is a little bit different, right? This will require us to sketch out a triangle, right? So notice that the problem we did earlier, I believe it was this one, right? Notice that the arc function was the outermost function, right? So we were able to evaluate the innermost function, right? And then just apply the correct interpretation to our arc cosine. But if you look at number 13 and then the problems after 13, the arc function is the innermost function. All right, so let's take a look at an example on number 13. Right, I actually show the solution to number 13. All right, so we're asked to find the cosine for the arc sine of 3/5. All right, so notice that the arc function is our innermost function. So in order to find the arc sine of 3/5, we're going to have to sketch out a triangle. Okay. So now keep in mind when you sketch out triangles, this is one thing that always applies. All students take courses, right? So remember that alludes to the fact that in the first quadrant, all 6 trig functions are positive. In the second quadrant, only the sine and its reciprocal, the cosecant, are positive. In the third quadrant, only the tangent and its reciprocal, the cotangent, are positive. And in the fourth quadrant, only the cosine and its reciprocal, the secant, are positive, right? Everything else is negative. So we want to sketch out the arc sine for 3/5. Now, based on the arc sine, right, it can only lie in the first quadrant or the fourth quadrant, right? Notice that all students take courses. Our sine is positive only in the first quadrant, right? Because I'm restricted to two quadrants, either the first or the fourth. So I know that my angle has to be in the first quadrant, right? That's just based on the fact that the sine is a positive value. And it's also based on the fact that the arc sine runs between runs between negative pi over 2 and pi over 2. So I'm going to sketch out an angle in the first quadrant, right? And I'm going to drop a perpendicular, and this is our angle theta, right? So now as far as the sine is concerned, the sine of any angle is the y value over the radius, or y over r. So we're given that the arc sine is 3/5, right? So I know that my y value should be 3. So remember, we're on the x and y axis. So this is r, this is y, and this is x, right? So I'm given y as 3, and I'm given r as 5. All right, now I can actually find x by using the Pythagorean theorem. So here are the formulas for that Pythagorean theorem. So r is equal to the square root of x squared plus y squared. X is equal to the square root of r squared minus y squared. Y is equal to the square root of r squared minus x squared. Right, so I can find x. X is going to equal to the square root of r squared. So that's 5 squared minus y squared, which is 3. Right, so this is the square root of 25 minus 9. 25 minus 9 is 16, and the square root of 16 is 4. Right, so x is equal to 4. All right, so I have my x, my y, and my r. So now I need to find the cosine for this angle. So remember that the cosine is x over r. So if I take the x value, which we just found at 4, divide that by the r value, which is 5, we can evaluate this as 4/5. Right? So we had to sketch out a triangle. Right? Once we sketched out the triangle, we were able to use the cosine as x over r as our solution. All right. So at this time, I'm going to give you a problem to do. Okay, you're asked to find the sine for the arc tangent of 3/4. All right, so I'm going to give you a few minutes to solve this problem, and then we're going to return with the solution. All right, so we're going to return with the solution. So since we have the arc function as the innermost function, we're going to sketch out the triangle. All right, so remember, all students take courses. The tangent is found, the arc tangent, excuse me, is found within the interval from negative pi over 2 to pi over 2. So we're concentrating on the right-hand side of the unit circle. The tangent is positive only in the first quadrant, so we're going to sketch out an angle in the first quadrant. Right, so we're given the tangent as y over x. Right, so our y coordinate is 3, our x coordinate is 4. Right, so y equal to 3, x equal to 4. Right, and if we were to find r should equal to 5. Right, so remember, r is equal to the square root of x squared plus y squared. So we have 4 squared plus 3 squared, 16 plus 9. Right, the square root of 25 is 5. Right, so r should equal to 5. So now we can pull out the sine since we know all of our values. So we can pull out the sine as y over r, or 3/5. So we can evaluate this as 3/5. All right, so I'm going to actually end the lecture here.